Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 11, Work and Energy. So if you remember, in the last class, that is in part 2, we started with the exact actual lesson discussing about work and energy, right? So in that part we discussed about what exactly work is. Like we discussed on scientifically how can we come up with the concept of work, because like if I am talking to you, I am teaching you about work and energy, I'm not doing any kind of work, right? And you listening to me, making your own notes, revising it, is not a work. Why? Because there is no displacement, right? And there is like no force exerted on the object as well. These are the two conditions which have been required. Well, first is a force should be exerted on the object, and the second condition is that there should be displacement of the object, right? Then only we can say that a work is been done. So if both of the conditions are not met, we cannot say that the work is been done. Okay, so like scientifically now we know what exactly work is, and we have discussed it so far in detail along with two different activities where you even wrote about the situations where you thought that it was work but actually it wasn't, right? Like I told you, now I'm teaching you and you are listening to me making your notes is not actually a work, right? So I want each one of you to please revise each and everything that we have studied so far. Like whatever we have discussed in part 1, you even have to revise that. I hope every one of you all are revising the basic parts as well that we had discussed in part 1. I hope every one of you have revised whatever notes you have taken so far in the lesson. So I'm going to show you like all the parts one by one now. Like we started the lesson by discussing on work in short, right? So here we have the most exact thing where we have different, you can say, situations which have been given when the work is done or when work is not done, right? So I want each one of you to please go through the slide properly. I hope every one of you are going through the slide very properly. So sorry. So after this, we had this activity which I want each one of you to please go through. I hope you all are going through this activity, and even you can go through the answers like or the points that you have written in your book regarding the same. Okay. Then we discussed on the scientific conception of work, and I want you all to please go through it as well, everyone. Now you have to even go through the situations that you have written. Okay. After this, we discussed on this activity as well, where you might have also taken many of the points, right? So I want you to please go through it as well. So till here you should be like very much thorough with the concept of work. Now we have one more activity and then we have other concept of work to discuss, which we will be doing as well in this part. Now we have this activity 11.3 to discuss. So see what they have stated over here. Think of situations when the object is not displaced in spite of a force acting on it. Now, if I say think of a situation like you pushing a wall. I'm giving you this example since like part 1, because I think that that can be one of the best example when when you exert so much of force, but still what happens, like the object is not displaced. So what in that situation, like do you think work will be that in, like work will be done in that situation as well? And also think of a situation when an object gets displaced in the absence of a force acting on it. So the object is getting displaced even when the force has not been applied. Like let's say for plastic, if it keeps on moving from one place to another, so in that case what is happening, the object is getting displaced without any kind of force acting on it, right? So now I give you two examples. You have to list all the situations that you think of for each, like when the force is applied but the object is not moving, secondly when the object is moving but the force is not applied. So you have to list all the situations which that comes to your mind and discuss with your friends whether work is done in these situations or not. So I want you all to come up with a list. Come on, start thinking of the situations and write them in your book itself, so that like you can go through further, like because you need to be aware of the situations as well where you're not applying any force, still the object is getting displaced. Okay. I hope you all have started like coming up and you are like started writing the situation as well. You need to at least come up with 5 situations, 5 to 6 situations for both. After this activity, now we have the next topic to discuss, that is work done by a constant force. So do you think is there any kind of work that has been done by a constant, like because of the constant force that keeps on acting on it? So we will be studying that over here. See, how is work defined in science? Now we know, and to understand that properly, we shall first consider the case when the forces acting in the direction of displacement. What do we need? We need to like consider the case where the force will be acting in the direction of displacement. Okay, so let a constant force capital F act on an object. Okay, what we need to do? We need to let a constant force capital F act on an object and let the object be displaced through a distance s in the direction of the force. Now F, we are representing F as a constant force. S is the distance, like object which has been displaced through a distance s, and then W be the work done. So F is the force, S is the distance, and W is the work done. Okay, so we define work to be equal to the product of the force and displacement. Work is going to be equal to product of force and displacement. So like if you remember the first part, I already gave you this formula in the first part where we came up with that work is equal to force into displacement, and that displacement is S, right? So work is equal to product of force and displacement. So force into displacement, that is F into S, and thus work done by a force acting on an object is equal to magnitude of force, F is magnitude of force, multiplied by distance moved in the direction of the force. Getting it, everyone? What is work done by force acting on the object known like is equal to? So work done by force acting on an object is equal to magnitude of force multiplied by distance moved in the direction of the force. Okay. I hope every one of you are taking a note of it. I hope every one of you are writing. You need to write the last part as well. Like you will be writing work is equal to product of the force and displacement. So work done is equal to force into displacement, that is F into S. And then you will write that work done by force acting on an object is equal to magnitude of force multiplied by distance moved in the direction of the force. Okay. So work has only magnitude and no direction. And if you remember that while we were like discussing part 1, I told you that time as well that work has only magnitude and no direction. So in equation 11.1, if force is equal to 1 Newton, if force is 1 Newton, we know that the unit of force is Newton, right? So if force is equal to 1 Newton and distance is equal to 1 meter, we know that distance has been measured in meters, right? So in that case, the work done by the force will be 1 Newton meter, because work is equal to force into displacement, a force into distance, right? So force is, the unit for force is Newton and for distance is minute. So the, you can say the unit for work becomes Newton meter. Okay. So thus the unit of work is Newton meter, that is represented as, like, Newton will be capital N, meter will be small m, or it will be joule, that is capital J. So either we can use the unit as Newton meter, or we can use the unit as joule. Okay, so thus 1 joule, like this is 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of the action of force. Now please skip this part. I guess this is the lesson name that came in the PPT. So we'll just cancel it. And like the definition for 1 joule is amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Okay, so look at equation 11.1, and that equation is W is equal to F into S, right? So look at the equation carefully. What is the work done when the force on the object is 0? Just imagine that the force on the object, like the force acting on the object is 0. So in that case, what will be the work done? And what will be the work done when the displacement of the object is 0? So we can refer the conditions that are to be satisfied to that work is done. And we know that there are two conditions that needs to be satisfied. One is force should act on the object. So if force acting on the object is 0, there's no work done, right? And the second condition is it should show some displacement. The object should have displacement, right? So if there is no displacement, or if the displacement is 0, then in that case also no work will be done. Okay. So I want you all to write this part as well. I hope you all are writing it. So I hope every one of you are done with it, right? So we can start with this example now. Now what is the example? You can see there are two bricks which have been kept. A force of 5 Newton is acting on an object. How much force is acting on an object? A force of 5 Newton, right? And the object is displaced through 2 meters in the direction of the force. So first is the where you can see 5 Newton written. This is the actual position of the brick. Okay, I'll show you. Okay, so this is the actual position of the brick, and it has been displaced through 2 meters. So from here it has been displaced to this position, and the distance is 2 meters. Okay, so if the force acts on the object all through the displacement, then the work done is 5 Newton into 2 meters. And when we multiply that, because we know that the formula for work is force into distance, right? And force is 5 Newton and distance displacement is 2. So what will be the answer? Work done will be 10 Newton meter, right? Because force is represented in Newton, distance in meter. So either we can write Newton meter or we can simply write Joule. Got it, everyone? So this is how you're going to continue it for all the other parts. So I want you all to please quickly go through the part, and like even you can write this, take a note of it in your book, which will make it easier for you to study further. I hope every one of you are taking a note of it. After this, now consider another situation in which the force and the displacement are in the same direction. So the direction of the force and the displacement, they are in the same direction. So the question is, a baby, like the example is a baby pulling a toy, like a baby pulling a toy car parallel to the ground as shown. What is the baby doing? Baby is pulling the toy car parallel to the ground. So the baby has exerted a force in the direction of displacement. He is like the baby is pulling the car towards the same direction in which he is applying the force, right? So in this situation, the work done will be equal to product of force and displacement. Got it? Because we know work done is equal to force into displacement, that is F into S. Then in such situation, the work done by force is taken as positive. So when the force applied is same, the direction in which the force applied is same as the direction of displacement, then we say that the force done, like force is positive. Okay. So now consider a situation in which the object is moving with a uniform velocity along a particular direction. What is happening? The object is moving with a uniform velocity, and that too along a particular direction. Now a retarding force, that is F, is applied in the opposite direction. So in this case, what has happened? Force F is applied in the opposite direction. In that case, the angle between the two directions is going to be 180 degree. What is going to be 180 degree? So let the object stop after a displacement S. Okay. When it should stop after a displacement S, and in such a situation, the work done by the force F will be taken as negative, and we will be denoting that as a minus sign. So plus sign when it is in the same direction, both force and displacement when they are in the same direction, we are going to consider that as a positive sign. If they are in opposite direction, then we are going to consider that as a negative sign. Okay. So the work done by the force is F into negative sign, so minus S or minus F into S. And it is clear from the above discussion that work done by the force can either be positive or it can be negative. So for understanding that, we will be doing one activity. Okay. But before that, I want you all to please write all the important points from the screen. I hope you all are writing it. You can even write the part from here, like activity I'm going to start with in the next part, not in this part, but make sure you know that how we consider the force to be negative and why do we consider it to be positive again. So you should be knowing the reason for considering force as either positive or negative. Okay, and you should be even knowing the formula for work that we just found out, that is equal to force into displacement, or you can say F into S, that is distance. Okay. So after this, like we will be discussing on this example, how to exactly calculate the work done in the next class, and then we will be starting with the energy part, like what exactly energy is, everything in detail with respect to energy. Okay, we'll discuss them all. Then we have this activity. Now as you know, there are so many activities in the lesson, we'll be discussing them all. Then we have the different forms of energy that you can remember as else, that is electrical energy, light energy, thermal energy, sound energy, heat energy, right? So we have different forms of energy to discuss. Then we'll be learning on who exactly Joule was and how exactly the unit of Joule came up. Okay, then we'll discuss about kinetic energy in detail, how exactly we derive the formula for kinetic energy, that is half mv square. And if you remember part 1, I have already taught you with respect to this, right, about kinetic energy in detail. Then we have like 4 different activities continuously, which is going to help us to know more about like kinetic energy and to practice more examples with respect to that. Then we'll discuss on potential energy in detail. We have this activity 11.8, 11.9, 11.10, 11.11. So all those activities are going to actually help us a lot, and if possible, if you have all the materials which have been required with you, make sure you all do the activity, because that is going to help you a lot. You will have the actual like real life based examples to discuss on. Then we will discuss on the potential energy of an object at a height in detail. Then we have like example to discuss, and then we'll discuss on are the various energies that we have, are they interconvertible or not. So we'll be discussing them through activities. Then we have like law of conservation of energy to discuss in detail, we'll be discussing on that. Then we have activity 11.5, we have like rate of doing work to discuss. Okay, then activities to discuss, examples to discuss. Then we have commercial unit of energy, we'll be discussing on that as well. Then we have again activities, and we have the summary to discuss at the end of the lesson, work and energy, which is again very important. Okay, so we'll be doing that as well, we'll be discussing the summary in detail. Then after discussing the summary, we have like 21 exercise questions to discuss. So I'm going to show you all the questions one by one, which I want you all to please go through very well, so that like you are also aware of what exactly we are going to study later. Okay, so everyone please go through these questions properly. I hope every one of you are going through the question that I'm showing you on screen. We will be discussing them all at the end. Okay, so sorry. So this is the last question that we will be discussing for the whole lesson, that is work and energy. Okay, so this is how we will be ending up with the whole lesson, work and energy. And as I tell you in every part, please keep on revising whatever we have discussed so far in the lesson, because like it's ultimately going to help you in elaborating your answers and framing your own answers, right? So I'll end up with this part over here and I'll continue with the energy part in the next class. Thank you everyone. So sorry.